Now, all right, in the last question, actually, we missed one of our solutions, which was in our cast system, and you reminded me. Um, we had our points, if you remember, which are important. Uh, da-na, 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 da-na. Now, we draw our cos wave, let's say. Okay. And remember, we had, when we had factored it, we had, sorry, it was cos 2 pi, cos 2, sorry, not pi, theta, is equal to, is it positive or negative a half? Positive a half. The other answer was cos 2 theta is equal to negative 1. Okay? Let's go about this. And within our restrictions, the restrictions we had were between 0 and theta is between 0 and 2 pi, right? So in our cast system, we have our C, A, S, T, quadrant 1, 2, 3, and 4. Okay. One way to look at this is we can actually draw straight lines across from our two answers. One of our answers was at a half. Okay. And at a half, if you notice, this is about a half here of y. Oh, sorry, we're at positive half. 3. This is about a half. I actually intersect the line twice here. Okay. Our other answer was at negative 1. Negative 1 is tangent. Okay. So because negative 1 is tangent, I'm looking at 1, 2, 3 solutions. Okay. So because it crosses it twice, there's 3 solutions. In fact, the idea of discovering how many solutions are, let's say if we had something like a wave like this, between this point and this point, and they wanted us to solve it at a half again. 1, 2, 3, 4, 5, 6, 7. I'd have 8 solutions there because it's crossing the line 8 times at that point. Okay, so that's the idea. When you draw a wave, it's going to give you an idea of how many solutions are going to be to the problem. Okay, what was important is we did solve. We solved over here our cast system. We had our special triangle, if you remember. We had 2, 1, root 3. Okay, and we discovered that that angle there was pi over 3. Okay, so that rotation was pi over 3. We set it equal. We solved for our answer. Our other triangle that we forgot to set up, because this is all are positive. Remember, we were looking for positive answers here. C, we're also positive in the 4th quadrant. So in the 4th quadrant, we should have set up the same type of triangle. And again, we have root 3, 2, and that's 1 again. This only problem is this is pi over 3 this time. This distance here is pi over 3. Well, I'm actually looking for more rotation from the beginning. So I need to come all the way around to that point. So essentially when I pass here, I'm passing pi over 2. I'm passing pi. I'm passing 3 pi over 2. Okay. And finally, I'm getting, my final answer is 2 pi. I need to rotate backwards if I got all the way around to be 2 pi. I know if I go all the way around, it's 2 pi. So I need to actually step back pi over 3. That's what that distance is there. So I'm going to actually subtract from 2 pi. My 2 pi, if I subtract my pi over 3, that's going to give me what our red rotation was to get to that point. So obviously I got to make a denominator of 3 here. So we're going to end up with times 3, so 6 pi over 3, subtract pi over 3. That'll give us 5 pi over 3. Okay? So that's our 5 pi over 3, is that full rotation. And the same idea is because it was our cos, we're dealing with this question again. Our cos 2 over a half. Again, we discovered that our cos, our adjacent over hypotenuse, 1 over a half, is also equal to 5 pi over 3. So I can drop the cos in the half. I get 2 theta is equal to 5 pi over 3. Just like I discovered that 2 theta was equal to pi over 3, remember before? When I brought the 2 over, I ended up with pi over 6. And the same idea is going to happen here. I end up with theta equals 5 pi over 6. Again. That's our other answer. So we have 1, 2, and our third solution, remember we found it down there, was 3. So we've discovered 1, 2, and 3 solutions. This was our pi over 6. This is our 5 pi over 6. And this one ended up being, what was the final answer in that one? Pi over 2? And the final answer was pi over 2. So we have our 3 solutions there. Does that make sense to you? Yep. Okay, so that's how we found the many different solutions. So, okay, we found our 3 final basic solutions. Here it is. The only difference is we have cos 2 pi, 2 pi. So in other words, this wave's period has shrunk. Okay? Because it's 2 theta, instead of the wave going down and then ending at 2 pi, it's essentially like the wave comes down and comes back up again at pi. So, let's say it in green. At a fourth, we go down, we touch here, up, down. We'll talk about what I'm doing in a second. The period of this function has shortened to 2 pi. So just like I draw on this red one over here, instead of having one solid wave, because it was 2 theta, this wave's period had shrunk, so one period exists within pi, but they want us to solve all the solutions within 2 pi. So in other words, it goes down again, comes up again. So now if you notice, we have 1, 2, 3, 4, 5, 6 solutions because the period of this function changed. All they did was they took our 3 final answers. Our other answer we had was theta equals pi over 2, right? Yeah. So we had our 3 final answers. Because the period shrank by a pi, we had to add a pi to each of the solutions. So we have solution 1, 2, 3. Solution 4 is just solution 1 plus pi. Okay? So in other words, that gives us our 11 pi over 6. Does that make sense? Add that? Okay. Solution 5 is solution 2 plus pi, so pi over 6. That's not plus pi. That's going to give us our 7 pi over 6. And finally, solution 6 is solution 3 plus pi, which is going to give us 3 pi over 2. Right? So we now have 1, 2, 3, 4, 5, 6. And the whole idea behind that is, that was my fault. I didn't realize it had a period shift. Because the period shift happened between there, our tangent lines, it now touch that wave 6 different times. Oh, okay. Okay? Does that make sense? Okay. So because the period changed, we got double the